Assalamualaikum warahmatullahi wabarakatuh. My name is MUHAMAD and the JAMILUS. So first of all, I'm gonna tell about the chapter one for the profile and the photo one for the photo, and I'm gonna tell about our group members. So first of all, I'm gonna be ALIFF and AINUL genders, and the second member is Haikal Hashim bin ABDUL, and the third one will be SYAHIR bin RAMLAN, and the last member is FADLIN bin RAHIM. So for chapter 2, introduction and appliance. For the project, it can be seen that the importance of the power analysis cannot be overstated, because such systems include power transmission from one point to another. Power is the most essential quantity in the electrical utilities electronic communication system. Furthermore, every industrial and residential electrical item such as fan, motor, lamp, television, and computer has a power rating that indicates how much power it uses. Exceeding the power rating can permanently harm an appliance. 50 or 60 Hz AC power is the most popular type of electrical power. The use of the AC rather than DC allows the high voltage power transmission from the power plant to the end user. There are few appliances that can be done, such as it can be used for the power measurement, but it can be used to get the calculation for the instantaneous average power, maximum average power transfer, effective of RMS value, and the ampere power and power factor. Other than that, it can also be used to calculate the electrical consumption cost.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahir bin RAMLAN and my matric number is BN210115. Okay, I'm from group 9. That we choose the question is 11.4. Okay, the question is using figure 11.36. Design a problem to help other students better understand instantaneous and average power. Okay, as we can see here, the question it asks us to design. Okay, we go to this figure first. Okay, we can see here this R2 and then XC is series in parallel with ZL, and then this ZL is series with this R1. Okay, we go to the question that we designed first. This is our question that we designed, the value of every component here. Okay, we go to the step 1 first. Okay, as we can see here, this is our value and position that we designed it. Okay, for the first one, we will calculate the total impedance. Okay, this is our ZTH formula that we get from the position and the value. Okay, we can get the answer for ZTH is 6.8824 plus J4.4700. Okay, we go to the second step. We apply nodal analysis at the main node. Okay, we can see here this is our V1. Okay, and this is minus by our V source, and then divided by 5 is our R1 at the first place. And then this is our J4, and then this is our series area at the back. Okay, we calculate as we can see here. This is we got V1 is 11.819 degree 64,159 degree. Okay, we go to the next step. Okay, for the third step, we will find the current first, but we will find the current one. The first circuit at the front, the back circuit is the second lah. Okay, as we can see here, the I1 will use resource our input that given, and then minus by V1 that we find at the first, and then divided by 5. Okay, we will get the answer for I1 is 2.437 degree and 2.97 degree. Okay, and then this is our formula. This is our result for I1. Okay, and then we will find the current I2 at the second part at the back, and then this is our formula, V1 divided by 8 negative J, and then we will get 1.466 degree 71.284 degree. Okay, for the I total that we can get for the whole circuit is I1 plus I2. This is our I1 here, and then this is our I2 here, and then we will get for I total is 3.166. Our degree is 23.472 degree here because this is our current. Okay, for the last step, step 4, we will find the VTH. Okay, our formula is I multiplied by ZTH here. Okay, the answer that we get is 25.980, and then the degree is 56.477 degree. And then we go to the find the power, average power, but we will find the average power for every component. Okay, the component P1 is our component 1 is resistance R1. This is our R for R1. Okay, the formula is 1.5 multiplied by I2 and multiplied by R. Okay, our I, if we at the first place we will use I1 and this 2.437 as, and then multiply by 5 for the I1, for the P1, the power, because this is a first component. Okay, for the second component we must find the VR first. Okay, and how to find VR is basic formula, V equal to I multiplied by R. Okay, this is our I for the first place, we will use I1, and then our second component is J4. Then we will calculate, and then we can get 9.748 degree 87.003. Okay, and then we will find the power 2 at the second component. That means is J4, and then the power 2 is the answer is 0 lah. Okay, as we can see here, 1.5 multiplied by this first, and then multiplied by our I here, and then multiplied by cos, and then our cos will multiply by -2 here, and then minus with here. Okay, and then we can get our power 2 is 0 watt lah. Okay, for the power 3 is in our second part. Second part we will use I2 here. Our I2 is 1.66 degree 71 and 284 degree. Okay, as we can see here, the flow is same with here, but the I is different. The value of I is different because the place is different. And then we can get the answer is 8.596 watt for the power 3. And then we can go to the power 4. This step is same with this step at power 2. Then we can get the power 4 is 0 volt. Okay, our power max is every power is plus P1 plus P2 plus P3, and P4 we can get the power max is 23.443 watt here. Okay, you can see here, this is our power max. Okay, that's all for me. Thank you for Muhammad Syahir Rahman.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal Hashim bin Abdul Walid. My number matrix is DN210108. I will continue with the AC power analysis simulation. The software that our group use is Multisim. First, open the Multisim. Next, redesign the AC RLC circuit into the Multisim. Next, change all the value of the component and supply. After that, mark the component with the voltage differential probe. Next, click the simulation tab and pick the analysis and simulation and choose a single frequency AC. Next, insert frequency value and change the output into the magnitude or phase. Run the simulation to get the output. Then compare the output with the circuit to identify the output. Next, to find the impedance and maximum power value. First, mark the voltage and current to the circuit. Next, go to the simulation and cell analysis and go to single frequency AC and set the frequency and change the output to real imaginary. Add other expression of impedance and maximum power. Run the simulation to get the impedance and maximum power output. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FADLIN, and today I will discuss about the result and discussion for this project. So as you can see, we have results from both simulation and calculation. So there are the values that we calculate, such as ZTH, V1, I1, I2, I total. So okay, we can see the comparison of all the results in the table. So I will the result between the simulation and calculation have is not the exact same, but the value is in the range of each other. So you can see the table, and I will also include this in the report. So for the discussion for this project, so we discuss about AC power analysis application on the circuit, which is RLC, resistance, capacitance, and inductance circuit. So to achieve this objective for this project, our group calculate the circuit using a manual method to get the value that we want to measure. So after that, we do simulation using multi-sim software. So we can also get the value using the virtual simulation. So we compare the result from each other to see the similarities and differences. So what we conclude from this project is students can use software such as multi-sim and other related software to better understand this circuit and other AC circuits that we learn in this subject. But we need to still do manual calculation to enhance our understanding. So that's all from me. Thank you.
For the chapter 6, conclusion and recommendation. For the conclusion, the series of our RLC circuit is the series connection of the three basic electrical components: resistor, inductor, and capacitor. Because of the resistor impedance is the real number, and the inductor and the capacitor impedance are pure imaginary values. The overall impedance of the circuit is the sum of the three impedances and is thus a complex number. The second section, the circuit transient response is specific and presented. It entails assuming the circuit behavior when it is applied with the heaviside voltage stage. Three regions appear to be feasible based on the various solutions of the second order differential equation connected with the circuit. The signal slowly oscillates toward the permanent value V in an undamped response. The overdamped response is characterized by the gradual increase in the signal value toward the permanent value. The critically damped response describes the situation in which the signal rapidly approaches the permanent value. The circuit AC response is provided in the third part. When they are given an AC signal, the differential equation can be stated in the complex version to determine the circuit transfer function. The series RLC circuit behaves as a second-order low-pass filter when the norm of the function is shown. Alternative configuration, known as RCL and CLR, are studied in the final session by simply exchanging the component in this session. The second-order high-pass filter or the band-pass filter to be built for the same circuit. And lastly, for the recommendation, with this project, it can be said that the power analysis is important to every industrial and residential electrical item. It is highly recommended for the use of the power analysis in everyday electrical item, for it will bring a lot of benefit as an uncountable power will damage the electrical device permanently.